Now that we've introduced functions into our language, we have a lot of power for doing computation. But so far, all we can do is do computation on strings and on numbers. Still a lot of things we can do, but we'd like to not only have the ability to do strings and numbers, we'd like to be able to look at bigger collections of data. And the same way that functions let us group things together, common computations, ways of grouping data together into things we can treat as primitives, as simple things, is going to be equally powerful. And that's what we're going to talk about today. We're going to introduce two new kinds of data structures, things called tuples and things called lists. And so let's start with a tuple. A tuple is an ordered sequence of elements, which can include any different kind of element within them. Now, when I say an ordered sequence, I don't mean that the elements in the sequence are ordered, meaning smallest to largest. I mean that the sequence itself has an order so that I can get to different parts of the sequence by simply indexing, much like we did with strings. One of the issues about tuples is that they're immutable, meaning I cannot change values inside of them. And in fact, that's just like strings. Remember, we could take out parts of a string, but we couldn't change the inner pieces of Remember, we couldn't change the inner pieces of a string. How do we build tuples? Well, I've got examples here in this slide. I'm going to just show you some of these inside of a Python environment. I can create an empty tuple by simply giving it an open and closed paren. The parens designate that this is a tuple. We'll see why that's important in a second. So TE is an empty tuple. I could make another tuple by giving it a sequence of elements, the integer 2, the string 1, the integer 3, for example. I could print it out. It's going to give me back the same thing. And like with strings, I can index into them. So I can say, starting again at 0, what is the 0th element of the tuple? And because I'm indexing, I'm using square brackets or braces to get to it. And that gives me out the first element. As with strings, I can concatenate using basically the same kind of structure. So I could take T and add to it another tuple, say 5 and 6. And that gives me back the longer tuple, all concatenated together. And just like with strings, I can slice to get out portions of a tuple. However, I can't, as with strings, try and change them because they're immutable. So if I try and change the first element of T, say I want it to be 4, it's going to complain. It gives me a type error saying that this is not something that supports that kind of an operation. They're tuples. Really good. Okay, with those, I can now start adding up other kinds of pieces. Before I do it, though, let me point out one last thing, which is the funny thing about the example I just highlighted here. If I go to T, there it is, and I say, give me basically the first element, so T from 1 but up to 2. So give me the tuple, I should say, rather than the first element. Give me the tuple that basically goes from 1 but not including the second element. It gives me back a slightly funky looking thing. It gives me back an open paren saying this is a tuple. It gives me the element, but then it gives me a comma before the closed paren. That extra comma is telling me that this is, in fact, a tuple. And to see that, let's look at the difference. I could create a tuple by saying 1 and a comma, and it gives me back a tuple. What would happen if I did open paren and the string 1 close paren? Oh, it just treats the parens in this case as if they're scoping things, and it just gives me back the element. So for tuples, we have to give that extra comma to tell us that, in fact, this is a tuple and not just an expression that's going to reduce to a single element. So there are tuples. One of the nice things about tuples, they're really convenient for things like, say, swapping variables. So again, imagine I've got x and y and I want to flip the values. We saw this before. The first version won't work because I'm going to take x and give it the value of y, and then when I want to bind y, the value of x is lost. I could do it by creating a temporary variable. I've done that before. Hold the value of x so that I can move y's value into x and then take that temporary value and put it back into y. But tuples do it directly. So this is a perfectly legal command in Python that says, create the tuple with bindings for x and y by simply taking the opposite versions in that tuple. And that gives me a nice way, for example, not only to swap variables, it also allows me to nicely return more than one value from a function. So if I wanted to give back, for example, the quotient and remainder of dividing x by y, I could compute the quotient, I could compute the remainder. Return's only going to return one thing, but if I return the tuple of q and r, then I can bind it using an expression that has on the left-hand side a tuple of names. And that will give quote the value that q holds, it'll give rem the value that r holds. So tuples have some really nice properties. And in particular, it's letting us think about a tuple as a single construct, out of which I can pull out the pieces. Great. Another nice thing about tuples, they're iterable. Just like with strings where I can walk down them, I could do the same thing with a tuple. So here's a little procedure. I'm going to walk you through it. It's kind of a funky procedure. The idea is that I'm going to give getData a tuple. And that tuple is going to itself consist of tuples. Weird. But it says each element inside that tuple is itself a collection of things. And in particular, it's going to be a collection of ints and strings. And what I want getData to do is to create two outputs. So let's look at it. First, I'm going to set up nums to be an empty tuple. And that's how I do it, open, close paren. Words is also going to be an empty tuple. And I'm going to take all of the numbers and gather them together into a new tuple. And I'm going to take that in the following way. Here's my little loop. And notice I'm iterating over the tuple. I'm saying for t in the tuple. That says the first time through, t is going to be pointing to that. Second time through, that. Third time through, that. And what do I want to do? I want to get the number out. So I'm going to index in the first, or in this case I should say it better, the 0th element of t gives me that thing right there. And then the paren would just treat it as if it was a single expression. So the comma, as we've already seen, is important because it's going to give me that singleton tuple. And I'm going to add it into nums. And add here says concatenate. So nums is now a little longer tuple. And then I'm going to, for words, say if the word part, this part, if it's not inside things I've already gathered together, I'm going to do the same thing. So I'm basically gathering up the unique words as well as all of the integers. And so they'll get put into there. And when I'm done, I'm going to return the smallest number, the largest number, and the number of unique words that I found. And that's what the bottom part does. And if I were to run it, I've got a little example over here. I simply load that into my environment. And it didn't print anything out, but that's okay because my binding is I've now bound small to be the first part of what was returned. And that is the number 1, which was the smallest number. Large is the largest number, 7. And words should be the unique words, or the number of unique words, and there were 3 of them. So I simply ran that on a set of data. And what I want you to see here is how I can iterate over the tuples, treating them as if they're just a single construct, just the same I would with a range or I would with a string.